Hi, everyone. Let's start section 9.4 on proof by mathematical induction. It's a method of proof. And we're going to start with a humble stamps problem. You might think this is strange, but this is actually a kind of problem you see in computer science classes, including discrete math, like Math 245. Here's my claim, and there are various stamps problems like these. But here's my claim here. I can construct any integer amount of postage of 6 cents or more by using just 3-cent and or 4-cent stamps. So if I had a machine, like a counterfeiting machine, shame on me, that can produce infinitely many 3-cent stamps and infinitely many 4-cent stamps, I make the claim that if you give me an integer number of cents, 6 or higher, I can construct that amount of postage by just using these stamps. The idea here is that we're going to figure out what strategies we're going to use to get from n cents to n plus 1 cents, where n is at least 6. So how do we get from, well, how do we start with getting 6 cents and then moving to 7 cents, 8 cents, 9 cents, and so forth, forever and ever and ever, 1,000,000 cents, 1,000,000,000 cents. So we're kind of thinking of climbing a ladder, or in this case, the way I've typed it, descending a ladder down into the depths, that deep descent. First of all, we need to start with a basis step. Now, my claim begins with the case of 6 cents. All right, just constructively, how can we get 6 cents of postage by using 3-cent stamps and or 4-cent stamps? Well, I would use 2 3-cent stamps. You can see, by the way, that there's no way of getting 5 cents from these. So you can see why I started with 6 cents and not 5 or lower, because you cannot get 5 cents from these stamps. But 6 cents, you can construct that by taking 2 3-cent stamps. Now, here's the way to look at it. Instead of just going constructively, okay, how can I construct 7 cents? Think of it this way. Again, what strategies do we use to get from n cents to n plus 1 cents? So taking a look at this configuration for 6 cents, what can you do here in order to add 1 cent to the total value? How can you go from 6 cents to 7 cents beginning with this configuration? Well, we would keep one of the 3-cent stamps, but then we would convert one of the 3-cent stamps into a 4-cent stamp. So we're descending that ladder. How do we go from 7 cents to 8 cents? Well, we'd keep that 4-cent stamp and we change the 3-cent stamp into a 4-cent stamp. So one of the strategies seems to be, if you have a 3-cent stamp, exchange it for a 4-cent stamp. That seems to be an easy way to go from n cents to n plus 1 cents. Again, to go from n cents to n plus 1 cents. If there is a 3-cent stamp in your current configuration, trade it in for a 4-cent stamp. Trade the 3 in, whoops. Trade a 3 in for a 4 here. Trade this 3 in for a 4 here. But now wait a minute. When we go from 8 cents to 9 cents, unfortunately, we don't have any more 3-cent stamps. Are we stuck? Well, not necessarily. How would you construct 9 cents? Well, let's take 3 threes. 3 3-cent stamps. And you see that when we exchange 2 4-cent stamps for 3 3-cent stamps, then we're trading in 8 cents for 9 cents, and we're gaining a cent. So that seems to be another strategy. If you have 2, or I'll say this. In the absence of 3-cent stamps, so if there are no 3-cent stamps in your current configuration, like this one for 8 cents total, in the absence of 3-cent stamps, you know you have at least 2 4-cent stamps. So if you don't have any 3-cent stamps, you know that you have at least 2 4-cent stamps. You know that you don't just have 1 4-cent stamp because 4 cents was not included in this, right? We're looking at amounts of postage 6 cents or more. 4 cents is not part of the game. So if you have a configuration with all 4-cent stamps, you know you have at least 8 cents. You have at least 2 4-cent stamps. Right. So in the absence of 2-cent stamps, you know you have at least 2 4-cent stamps. Trade in 2 4-cent stamps for 3 3-cent stamps. And together, these two strategies will allow you to go from n cents to n plus 1 cents for any integer number of cents that's at least 6. Let's do it. All right. How do we get 10 cents? We keep 2 of the 3s, but then 1 of the 3s goes to a 4. We trade the 3 in for a 4. How do we get from 10 cents to 11 cents? We can keep a 3, keep a 4, but then trade in this 3 for a 4. So we now have 1 3 and 2 4s. That's 11 cents total. 12 cents. Trade in the last remaining 3 for a 4. 12 is 4 plus 4 plus 4, or 3 times 4. Wait, now we've run out of 3s. Well, I guess you could also reimagine this as 3 plus 3 plus 3 plus 3, but let's build on this. Let's build on this configuration. We have 3 4-cent stamps here. Remember, we can trade in 2 4-cent stamps for 3 3-cent stamps. I'll move this, oops. We can trade in 2 4-cent stamps for 3 3-cent stamps. And then this 4 goes here. This last 4-cent stamp goes over here. Of course, the order does not matter. Addition is associative and commutative. All right. So again, the 2 4s become 3 3s. We go from 8 cents here to 9 cents here. This 4 stays put. So we go from 12 cents to 13 cents over here. 3 plus 3 plus 3 plus 4 is 13. And then you can start changing 3s into 4s and so forth. So you agree that with these two, with this basis step, together, 6 is 3 plus 3, together with these two strategies, we can then produce and construct any integer number of cents 6 or higher. 6 or higher. You can construct 1,000,000 cents, 1,000,000,000 cents, your social security number, whatever. So if you understand this, you're well on your way to understanding induction. And that's a really critical thing, being able to understand induction. Some people take a long time to understand it. Many people never do. Okay, so I'm going to show you a couple of videos that are really going to get at the core of induction. You'll see.